Hey everybody, sorry I couldn't be at the meet today, so I thought I would do a quick little run through of how to do these lens diagrams, finish that up for you, and then show you especially how to do the two virtual image ones, which are a little bit harder than the real image ones. So I figured I'd go through that really quick, and I'll just kind of leave it up to you to take a look into some of the lens applications, some of that kind of stuff. So my apologies, just couldn't pull it off today. If you have questions, feel free to let me know. I just had something come up like I said this afternoon, and rather than trying to reschedule, I figured I'd just give you the afternoon off. So I hope you enjoy that. Go outside, do something pleasant, and enjoy the bonus time that you've got today. So for this, the couple things I'm going to do is I'm going to review how to do the lens diagrams for a real image. That's diagram number 3 is the one that I'll use here. And then I'll do number 5 and 6, which both produce virtual images, and then a quick little review of how to use the mirror and lens equation at the very end. So this will help you finish the last bit of homework, help you finish up with that lab, use your time well to go do something more enjoyable than sitting in a Google Meet this week. We'll have our Google Meets next week. It'll be fine. So for this one, we've got our converging lens here in the center. We've got our lens line vertically down the middle, and we're going to use that as sort of our geometric reference as we're drawing these. And then we've got our principal axis, horizontal down across the middle. We also have the F and 2F points marked, and again, they're marked on both sides of this diagram because when you're talking about a converging lens and it's symmetrical, it's got a focal point on either side, depends on which way the light's coming through. So we will use both of them here to get these diagrams drawn. So to do this, again, we're going to draw our 3 principal rays. And I'll use the kind of 3 different colors just so you can kind of see which ones are which. Principal ray number 1 always starts at the object and goes horizontally to that middle point of the lens line. Ignore that little one right there, that's a mistake. Once it goes parallel along the principal axis, by definition, all rays then will pass through the lens, refract, and pass through the focal point on the far side of the lens. Let's see if I can extend that out there. There we go. The second ray that we're going to draw, the second principal ray, basically is inverted to this one. So what this one is going to do is going to go down through the near side focal point and then out parallel flat on the far side. Imagine light going the other way through the lens. What path that light would take? It would go through the opposite side focal point. So that's pretty much the ray that we're drawing. So ray number 2 starts at the top, goes through our near side focal point, like that. If I can get it kind of lined up more or less like that. And then it's going to travel flat out from there, something like that. So now you can kind of see where our lens is going to start to go. I'm going to move my little picture over the other side here. So you can kind of see where this image is going to start to form. And again, if you're not sure like why this ray goes this direction, imagine light coming the other direction. Imagine light going, well, I guess screen-wise this way, right? Coming from offsite, from right to left across the screen, it's going to come in parallel and then bounce through that the other side focal point. So again, these are 2 sort of symmetrical rays relative to one another. Our third ray is the easiest one to draw, and this is the one that's going to go through middle. When we did it with our mirrors, we went through 2C because that was kind of the center of the sphere. Well, in this case, our center is actually the center of the lens itself. So it's going to start at the tip and go through where the lens line and the principal axis sort of meet one another. So it's kind of like that. And it should match over here on this side. I'm going to fudge it a little bit because I know mine's off a little bit, but that's kind of where they should meet on that side. There's always a little bit of error in this one, always, and that's totally fine. So again, if your line is just a little bit below, something along like, where is this? If I can grab it. If it kind of is more like that, it's okay. You know where that image is going to be. You know what direction it's going to be in, more or less what, how far it is from the lens. Basically what the height is, all of that kind of stuff. And that's really what we're looking for. So now we can kind of see where our image is going to be. Our image is where those lines are intersecting. So this intersection point, and I'll leave mine kind of messy just to show you, that's where our image is going to be. And it's going to be facing, in this case, downward. It's below the principal axis. That's a really bad arrow. I can't draw straight apparently, but that's our principal axis right there. Wow, I'm just horribly drawing today. So anyway, there it is. And it would be, in this case, upside down. So there we go. There's our sort of inverted image. So again, this is the typical way that we do this. We always do the kind of the same rays. We go in parallel to the principal axis and then bounce through the far side F. The second one bounces through the close side F and then exits parallel to the principal axis. And the third one just goes through center, goes right through the middle of the lens line and the principal axis. So center, and it does not refract at all. It literally goes straight through. The one thing I am missing from here is I am missing my virtual rays, which would continue from the bounced back refracted arrows. So there's our refracted arrows, our virtual rays that are coming back from that side. So if we're trying to interpret this sort of an image, and see, I still have my information that's on here from earlier, but if you're trying to interpret this sort of an image, because this is through the lens, this is considered to be a real image. It's facing downwards or below the principal axis, so it is inverted. In this case, just by looking at it, you can kind of tell that it's larger, it's enlarged, so our magnification will be greater than 1. It's bigger than the original one. As soon as you move inside 2F, your images are going to be larger than the original object was. So our signs here, again, just to review, DO and HO, height of the object, this is the object considered to be positive. DI is positive because it's a real image. Again, it is projected through the lens. You could catch that on a screen with real rays. So it's considered to be a positive DI. HI, because it is inverted, is considered to be negative. It's downwards facing. So even though it's a real image, it's upside down. Therefore, HI is negative. Our focal point for this type of lens, our focal length for this type of lens is always considered to be positive. It's a converging lens and is capable of producing real images. Therefore, it's given a positive focal length. And then our magnification here has 2 characteristics to it. Remember, it's negative because our image is upside down, and then it's greater than 1 because our image is larger. So this is the pretty straightforward one. Most of our lens diagrams are more or less exactly like this, with the 3 principal rays and those sorts of image characteristics. So what I want to do here today is do the other 2 types of ones that are a little bit harder, that have the virtual images to it. So let me go scan forward here. So here we have the case of an image or an object here where we're inside of F and we have a converging lens. But this one is going to form a different sort of image. So let me move myself out of the way here one more time. Move me down here someplace like this. All right, so there we go. Okay, so for drawing this one, we're still going to do our 3 principal rays, but lining them up gets a little bit trickier. So we still do the exact 3 same rays. So ray number 1, again, was the first one, and it started and went in flat and then bounced through F. So far so good. So in flat, we're going to start here. Our object is super close to our lens. There it is. Hits that lens line, and then it's going to go through F. So if I could actually get it to draw. There we go, through F like that. There we are. Ignore that little artifact there. That was a mistake. Then we also need to, for this particular case, draw our refracted rays. And this is something you should be doing anyway, but now it becomes critical to do it. So our refracted ray, one that's kind of bouncing off the wrong side, or the reflected ray, I should say, sorry, bouncing off the other side of the lens. I'm going to start mine back here just to get to my angle right. Goes this way. Okay, so there it is. And again, I started it way back there just to get the angle right, because with drawing on my screen here is difficult. There we go. So there's my reflected ray, sorry, bouncing back off of the lens. So again, that's principal ray number 1. Principal ray number 2 does the same thing as it did before, which was to go through the close side F and then to bounce back flat. So we have a little bit of a trick, though, in terms of how to get this one to line up. And that's because this is now inside of F. It doesn't go this way. I mean, I'm going to draw this one wrong. It doesn't go that direction because that ray never actually meets the mirror or the lens. Sorry, so that's not what we want to do. So it actually goes the other direction. So it's going to line up your ruler with F and the tip of this thing. So you're going to line it up just like you would the other way. But now you're actually going to continue your ray. Hold on if I can get mine drawn. The other direction. It goes up this way is the way that it goes. So again, it's going to go through F and up like that. If I get it to line up, there it is. So again, you would only draw this section up here, starting here and going up to the top. That's the way it does. Again, you line your ruler up from here to this, to the lens line, but you're only drawing this section up here. This isn't really a ray. Well, it is, but this is not the ray that's going to form the image. It's this part of the ray that's going to form the image. So again, the second principal ray, if you think about what it is, it goes through the near side F, and then it bounces back flat, or it refracts through flat. So here is part 2 of our refracted ray, and this should be also red. Let me make sure I get my colors right here. So part 2, our refracted ray is going to go through flat, like that, sort of like that. There we go. And then it's going to be our virtual reflected ray that's going to bounce back the correct direction and start to give us an idea of where that image is going to form. And it's going to be going back this direction. So now you can kind of see where this crossing point ends up being. So again, it's a little bit different. Again, you're going to line your ruler up in exactly the same pattern, but now it's the reflected rays, the virtual rays, that are actually causing our image to form. All right, our third ray is exactly the same. Our green ray, that's the one that goes through middle. And again, with this one, here is the middle, goes through like that. Fabulous. There it is. And then we also need to, once again, draw our reflected ray. I can't get those words backwards. And our reflected ray, I'm going to kind of get mine lined up. It's going to go through that direction like that. Again, mine's going to be a little bit off just because that's going to be how mine are going to work. I'll fake it. But there it is. So we can kind of still see where our refracted ray is going to end up being. It's somewhere over in this kind of range like that. So you can kind of see this. If mine's off, something's funky with how I have mine set up on my screen. So if you get some off like this, you can still tell where that image is going to be. But again, now it is the virtual rays that are meeting. This is not a real, this is something, an image that only exists in the lens. Now to you, what does it look like? This looks like a magnifying glass. So if you hold a magnifying glass, a converging lens, really close to an object, you're going to see in that lens a blown up, bigger version of the object, right? But that image only exists within the lens. It looks like it's really close to you, but it actually isn't. It's a virtual image. And a virtual image would be basically in this point right here. I don't know if I can get this to draw, but it would be in this spot right here, would be where our virtual image is, like that. And so you can kind of see that it is definitely a larger image than the original one was. So virtual image here. So again, when we're talking about our signs and analyzing this diagram, DO and HO are positive because they're always positive. Easy enough. DI and HI, okay, this gets a little bit maybe easier, maybe trickier. Distance to the image, because this is a virtual image now, our distance to the image is negative. I know that really throws students off, but because it is a virtual image, it is made from these virtual reflected rays, we give that a negative sign. And that's just by definition how these equations work. HI now, because it's upright, this one actually makes sense. It's upright, so the height of the image is positive because it's right side up, so that makes sense. Okay, F, this is still a converging lens. So we're still going to keep that same positive sign for F because it's a converging lens and is capable of producing real images. Even though this particular image here is virtual, this type of lens always is considered to have a positive focal length. And then magnification. All right, magnification, it is upright, so it is positive, and it is enlarged, so it is greater than 1. So that's our image right there. So it is a virtual image over here, again, made from virtual rays. It is upright and it is magnified. So again, this is how we use a magnifying glass, how we create a virtual image inside a converging lens, just by getting really, really close to it. And by getting really close to that object, it's going to really blow up the size of that image that you're going to see in that lens. Okay, it's time for our last one. This one is by far the most annoying one to draw. So I'm apologizing in advance in terms of how this one gets set up. This is one that throws students off more than any other one because it's very different. So our principal rays are still going to be kind of the same. So you're going to go in flat and then through F. And then you're going to go through F and then in flat. Or out flat, sorry. And then through middle. The thing that makes diverging lenses different is that you flip-flop which F you use. So here's what I mean by this. Okay, if this was a converging lens, our first ray would go in flat and then through the far side F. So we're going to start it off the same way. We're still going to do our first ray in flat. So here it comes in from the top, and it's going to go zoom to our lens line. Very exciting. Okay. Now, like I said, oops, I should have made that the other type. My apologies. That should not be a virtual ray. That's a real ray. So I want to make sure I fix the type of that. Okay, there we go. So virtual ray, real ray. Now, if this was a converging lens, we would aim through this particular F. But again, we're going to flip-flop which F we use. This is an inverted lens, so we use the inverted F. So now what you're going to do, instead of aiming your ruler towards this F, line your ruler up towards the close F. It's the opposite one from the one that we would normally use. And this feels really weird, but again, this is the kind of, I'm going to just do a dotted line here. This is the way that you're going to line up your ruler, through the close side F. That's the angle that you're going to use. So let me get my ray on there. Now remember that this is a diverging lens. So our rays should diverge through the mirror. When they refract away from one another. Again, I'm going to have to kind of cheat a little bit here to make this work, but it should be kind of like that if I've got it right. There it is. So there it is. That is our refracted ray. It diverges away from the focal point, and it's lined up with the close side, the opposite focal, the negative focal, if you want to think of it that way. So again, it's a little bit backwards. this case, our refracted ray, or the reflected ray, pardon me, is in line with this one, but it's going to be our dashed line. So it's going to come down this direction, and it should line up directly with F. So there's our reflected ray, like that. So again, with this one, you can kind of see where that one lines up. Again, you're going to line your ruler up with the opposite side focal point. Again, it's in flat and through F, but now it's the near side F. Okay, ray number 2. Okay, in our other types of diagrams, we would line it up to go through the near side F and then out flat. Okay, again, we have to flip which F we're using. So we're still going to aim it through our near side F, but now it's the opposite F. I know it's weird to say that, I know. So the way you are going to line up your ruler in this case, you're going to line up your ruler from here to here is where you're going to line it up. Again, it's this direction, sorry, this way is, if I can get it to line up right. Again, it's through the opposite focal point than you would use in a converging lens. So you're going to kind of line it up sort of that way. So that one is the one you're aiming for. Okay, so again, you're going to go aim it through F and then out flat. So here's how this ray looks for real. Let's see if I get my ray set up here. This is supposed to be the red one. Here we go. Come on, go away. There we go. So it's going to aim through the F, the far side F. I'm going to make sure I'm kind of in my right range there. Okay, so it's through there, so it needs to be about here. Again, I don't have a real ruler to set it up, but that's how it's going to aim. So again, I'm aiming at this far side F. When I'm lining up my ruler, it's the opposite F that I would normally do. And now this means that it's from here, it's going to bounce out flat. And again, these are diverging rays. They shouldn't meet on this side. That's a normal thing for this one to do because it's a diverging lens. Our reflected ray, again, is going to be in line with our original, or our refracted ray. So it's going to come back this direction. And now you can kind of see where the cross is going to occur. It's our reflected virtual rays are going to meet in this particular spot right here. Our third ray is the same. It is luckily the same as the other one. So it's going to go through middle, just like our other ones have. And hopefully these all meet, which would be really, really nice. They probably won't because, you know, that's my day. But they're going to meet. Oh, look at that. Strangeness. So this is the real ray is going through here. And then the reflected ray comes back along that same line. So it is this spot right here where our lens crossing is going to occur. So that's where our ray crossing is going to occur. So that's the location of it. Again, this is the weird one about this one is that you're using the opposite rays. So again, in flat and through F, but now the far side F. The second ray is through F and then out flat, but now it's through the far side F that you're lining it up and then flat and out. It's a little bit, it's just the backward side, the reverse F that you would normally use. And our third ray is the same, middle. So when you take a look at our image here, this is always the one that's the hardest one to draw, hardest one for me to explain to. It starts here and it's like that. So there we go, our little image right there. So if we take a look at our image now, this is a virtual image. It's on the same side of the lens. It's not through the lens, so it's on the same side, formed by virtual rays. It's upright and it's quite a bit smaller. So if you take a converging lens like someone's glasses, like if you ever grab some glasses like mine and you try to look at something, the things that you see through that lens look tiny when you look through it. So if you've got a pair of glasses around your house, give that a shot. Does not work with reading glasses. Okay, that's not the type I'm talking about. But for this, it does indeed work. So for this one, our signs, DO and HO, again, are always positive. So we're good there. DI, this is a virtual image. Therefore, it is a negative distance to the image. Again, virtual means negative. HI, it is upright. So it's positive because it is upright. Our focal point for this one now, this is a diverging lens. So please make sure that when you're using a diverging lens, you give it a negative focal length. And then for M, okay, M, it's upright, so positive, and it's smaller, so it's less than 1. Again, trying to draw these sorts of ones, these ones are the hardest ones to line up because they kind of fight all of your other sorts of instincts. And once you've built a pattern of where to line them up, again, the way that I interpret it is it's still the same through principal rays, but you aim it through the opposite side F as opposed to the side F that you do with the converging rays. I don't know if that helps or not, but that's how you draw these particular ones. It's a little bit weird. And then the last thing is just as a reminder, when you are doing the thin lens equation and the magnification equations, to be very careful about how you are assigning signs, the positive and negative signs. Oftentimes there is not any information in the text of the question itself to give you the hints as to what your signs should be. So I want to remind you that when you're using the thin lens equation or the lens equation, it's functionally the same as the mirror equation, but make sure you're very carefully checking your signs for F whether it's positive or negative, or if you're solving for it, then it may give you the correct value to it. But F being positive means it's a converging lens. F being negative means it's a diverging lens. The other thing is to remember that make sure that if you've got a diverging lens, that you're using your DI as negative, that it's a virtual image. Again, there may be hints in the text of the problem itself that say a virtual image is formed at 5 centimeters. You have to give that the -5 to make sure that you've got the right sign for that. So again, that's the most important thing to do with the thin lens equation. And then again, remember your algebra, that 1/f thing is kind of a weird, just let your calculator do the work for you. All right, with the magnification equations, again, similar. You just got to be really careful about using those text clues to make sure that you've got the positive and negative signs are correct. Your DIs are going to be positive if it's real and negative if it's virtual. Again, which side of the mirror is it on? So if you can kind of think about how this would work, even with the last one that we just did, we would have a positive DO and a negative DI. So think about the diverging lens ones we just did. Negative DI times a negative sign, that's a double negative, makes this whole thing positive. And if you remember from that, our image was upright. And that's what gives us that positive sign. So it's a negative of a negative, and that's perfectly normal to do that. Or if you have a real image, this is positive, and your real image is positive, and then you take that and make it negative to get an inverted magnification. So again, be very careful with that and make sure you're really careful. HI, again, positive if it's upright, negative if it's inverted. Most students are doing that one pretty straightforwardly. And again, your values for M are related to if it's upright or inverted. And then the magnitude of M. Again, it'll be greater than 1 if it's blown up, if it's enlarged, and it'll be less than 1 if it's reduced. So there you go. Sorry I couldn't be at the meet today. I hope this little kind of video will help coach you through doing your own thin lens diagrams, especially for those virtual images, and help you get your homework done. So there you go. Enjoy your afternoon. Sorry I couldn't be there, and I will see you guys soon. Have a good one. Bye, guys.